Okay, 29.4, asteroids, comets, and meteoroids. Real exciting. I love this section just because of all the amazing things that happen during that period. It's exciting, and we get to see a lot of it in our nighttime sky, sometimes in our daytime sky. So our objectives are going to be describe the physical characteristics of asteroids and comets, and compare and contrast meteoroids, meteorites, and meteors. They all sound similar, a little bit different. So let's go ahead and start. First of all, asteroids, comets, and meteorites, they're all flying around out in outer space. And if we think about what our solar system is, we've got a bunch of dust and ice and chunks of stuff, leftovers, flying around out there. So the first one that we start with is an asteroid. Basically a giant chunk of rock just sitting out there that's orbiting around. Now it's flying around, crashing into stuff all the time. Remember my favorite video game, one of the first video games I got to play in the arcade, Asteroids, and they were all bouncing around each other. And we think about asteroids in the movie Star Wars and things like that. Well, they are giant chunks of rock, and we can't count them all, but we know that there are millions out there. And so they're flying around. They're all part of our solar system, and they're hanging out there. Now, generally they have what we refer to as an elliptical orbit. Again, we remember what an ellipse is. It's basically a oval or a circle with two foci or focuses. They act like the planets. They're following a particular orbit. And so if we think about the longest one that we know, the longest asteroid, about 1,000 kilometers in diameter. This is a big chunk of rock. We refer to those as planet killers. So what can they be? Well, sometimes they can be the remnants of planets and different things. Sometimes they can fuse together and solidify as well and become bigger. And so basically they're flying around out there. I thought this is a pretty good image of an asteroid. You've got planet Earth in the background here. I thought that was pretty cool. But this is an asteroid chunk that's floating around out there, and you can see that it too has been impacted. Look at the impact craters on this thing, right? So it's flying around, it's getting beat up at the same time. So where do they hang out? Well, they hang out in an asteroid belt, and the asteroid belt is basically between Mars and Jupiter, and that's where most of them are, but some of them escape, and we'll talk about those in a minute. 100 million kilometers past Mars to 150 million kilometers towards Jupiter. That's basically where they're at. Most of them you can classify either in carbon, iron, nickel, silicate. So you can classify these pretty easily. So you have your carbon ones, your iron and nickel ones, and your silicates. Sometimes we refer to the asteroids as a Trojan asteroid, and those are the ones that are pretty much located near Jupiter. Again, they're hanging out there. But then we have the Earth grazers, and I refer to these as the ones that are going to whiz by Earth and come very close to Earth. And if they're big enough, we call them planet killers. The one that struck the Yucatan Peninsula that caused the 5th mass extinction on the planet would be, it was not a planet killer, but it was a game changer. It was a massive, massive asteroid. I'm sorry, I take that back. That was a meteorite that struck that. But anyhow, very, very big, very big. Comets. Comets are easy. Big body of rock. But this one's different, right? So there's ice and methane and things that are in there. And as it's going through the solar system, what happens is it's starting to break down. And so as it breaks down, we have the core, or the nucleus, the middle, which is the ice and rock. And then we have the coma, which is the gas as it's melting, right? So it's melting, and it's creating this gas around the outside of it. And so this gas and dust, as it does that, is the coma. And then we have the tail. The tail is what is dragging on behind, but also dragging in front sometimes. And I'll explain what that means. So what happens is solar winds are pushing the tail the direction of which it's going. And so you would think, oh, it's trailing it. Well, not always. In fact, if a comet is going towards the sun, it would be on the back side. And then if it's going away from it, it would be on the front side. So no matter which direction it's moving, the tail is always pointed from the sun. And the most popular one that we think of is Halley's Comet, and we'll talk about that in a minute here. But they can have the tails being in excess of 80 million kilometers, which is a long way. So here we got the nucleus, which is the main part of the comet. We have the coma, which is the gas streaming off of it, and then the dust trail. And again, this could be as much as 80 kilometers. And so knowing what we know, the sun would be on this side, pushing that way with the tail. So if we look at the Oort Cloud, okay, so the Oort Cloud basically is a area that we think has as many as 1 trillion comets. And it's, again, bits and pieces of ice and rock, and they're flying around out there. And so the difference is it could take each one of those so long for it to circle the solar system. Now, things like Halley's Comet is a little bit different, or Comet Hale-Bopp. We'll talk about those. So again, this cloud is a very, very large area, and it's flying around out there, and they could have millions or trillions of ones out there. So long period comets, something like 100,000, a million years long. Short ones, hundreds of years. So these guys are hauling major booty through the universe and through the solar system. And so when we think of that, we think of Halley's Comet. And so I actually saw Halley's Comet in 1986. It has a 76-year cycle. The next appearance, when do you think? Write the answer down on your paper and make sure you plan your calendars. So this is Sir Halley. And again, we've talked about retrograde motion, but if you think about this, this particular comet is going in a different direction than the planets are. So this is Halley, and oh, I just gave the answer away. Sorry about that. So again, it is in an elliptical orbit, and it is going through the solar system, being pulled by the gravity of the sun. Oh, I didn't give it away. This is 2024. So this is at the other side of that. So anyhow, so this is what a comet would look like in outer space. Meteoroids, bits of rock and metal that move through the solar system. Okay, they break up, maybe from broken asteroids. Again, asteroid is really huge. Meteoroids, meteorites. No, I guess I was right earlier. It was an asteroid that struck, not a meteor. So anyhow, the Yucatan Peninsula. I had to think about that. So meteor, brilliant streak of light caused by meteorite burning up in the atmosphere. So I want to show that. So here's the deal, though. It's basically a meteoroid is a piece of material whizzing through the solar system, rock metal. Now, once it strikes the Earth's atmosphere, it's a meteor. I've got some really cool images that I thought I'd show you of meteors in the nighttime sky. These are videos.
Texas, where the night sky lit up, and so did the 911 phone lines. Police fielding hundreds of calls from people who saw a blazing fireball or who heard what sounded like an explosion. And ABC's Tom Yamas reports more scenes like this could be on the way.
Tonight, across central Texas, many are asking, did you see it? That fire in the sky that some say caused a sonic boom.
We heard an explosion here on 5-7.
You can see the fireball on this dash cam video, and look at it here on this police cruiser cam. NASA confirming to ABC News it was a meteor, 4 feet long, 4,000 pounds, traveling 55,000 miles per hour.
It looked like it was across, like in towards Mexico.
Just last week, people in several states saw fireballs racing through the sky. And overseas, check out this one streaking over Japan. NASA estimates nearly 50 tons of meteorite reach our atmosphere every single day. The reason we don't have to wear helmets? The vast bulk of it burns up in the atmosphere. But massive space rocks sometimes do hit and hit big, like last year in Russia. The shockwave blowing out windows, hundreds injured. And right now, the time to be looking up. 3 different meteor showers peppering Earth, meaning we'll see more of these images that are out of this world. Tom Yamas, ABC News, New York.
To Texas, where the...
All right. Another one I wanted to show. This is the explosion of one. I thought that was really, really good.
Right.
This is basically the breakup in the outer
Nice
atmosphere.
flashes. Oh, wow. Down, lower right, lower right.
And then this one here, this one's incredible, just shocking actually.
Bro, you see that?
A couple guys.
What?
Oh! Sorry, I was just having some fun. So that really didn't happen. So, all right. So basically, a meteor, once it hits the atmosphere, it's cooling off, and so as it cools off, it wants to break up. And so when we see them streak across, I'm sorry, it heats up. It's heating up when it hits the atmosphere. I'm still laughing about that last one. As it heats up, as it hits the atmosphere, it's slowing down. As it does, it starts to break up. When we see this burning up of this thing, it becomes a shooting star. Make a wish. That bright flash as it hits the atmosphere, a fireball, right? And so, as it does, we sometimes hear a couple of things. As it's breaking up the explosions, we also hear possible sonic booms as it's traveling so fast. So, you know, the difference between a meteoroid and a meteor. Meteoroid is before it hits the atmosphere. Meteor is when it hits the atmosphere, aka shooting star when it streaks out, and the fireball is as it's vaporizing quickly and giving that giant flash. A meteor shower, we have lots of them, and basically there are periods of time where we actually intersect the path of a large number of meteoroids. The comet's path, if you will, as it breaks up, it has bits and pieces, and those things can fall to us. And again, we saw the poundage or the kilograms falling to Earth every day is amazing. A meteorite is the piece that's left over after it strikes the surface, right? So these are very expensive, and people pay a lot of money for them. So our basic three types: stony, iron, and stony iron. Again, what's in them? Basically, same composition of Earth, which would be a stony. Iron would be, again, having a metallic appearance, and then iron stony being a combination of the two. Now, interestingly, the iron ones are the easiest to find because you can use a metal detector to find them. So, to review asteroids, comets, and meteoroids, our objective was to describe the physical characteristics of asteroids and comets, which we did, and then compare and contrast meteoroids, meteorites, meteors in the outer space, in the atmosphere, and on the ground. You guys did a great job. Thanks for listening. I hope you have a